So I'm going to review single linked lists today, and then do a couple of the quizzes. Already compiled this time. This one already went over a bunch of times. Just maybe dangling pointer has something to do with initialization. It allows you to initialize an element without allocating memory. Or initialize memory without allocating the actual memory. I think that's how it works. I'm gonna ask anyway, just to remember. Ask Gemini this time. I've been using Gemini, so I think might run out of free credits. This should be similar to the other ones, I think. So an option, from what I remember in Rust, is a type that allows you to wrap other types in order to say whether or not they are null. And this is a problem on other languages. I don't remember really well why, but I know that it is a massive problem, and I think that there's something about JavaScript causing $1 billion in losses or something like that because it has null. That's what they were trying to avoid, if I remember correctly. But there is another type which is the result, which is basically very similar to this one, but then it only works for. I think maybe the option only works for structs, but maybe not. I think the result only works for structs, and it's basically the same idea, but instead of only returning, the option returns either some or it wraps the other type on some or none, and the result wraps on OK or error. The result is for handling errors or handling the return functions, I think, and this one is just for allowing you to check whether or not a type has or a value has something or not. And usually use this when you do operations where obviously you're not sure if you're still gonna have the value, and then you check on the match. Use the match statement to check whether or not you got something or you got none. So here makes sense. Box is kind of like a unique pointer in C++, but in Rust. A pointer type that uniquely owns a heap allocation of type D. Okay. Wraps the node, has the elements, and another pointer to the next one. That makes sense. Is it alloc? It allows you to do manual memory allocation on Rust. It's the SD alloc or alloc. The initialization a little bit different because it doesn't allocate. It doesn't use the layout from the other previous solutions used. Now obviously I think makes sense because it's a different type of thing. Because you don't need the memory. I think you need to allocate the space in the heap before. Just allocate for each node, I think. You just create the new box, create the element. When you're pushing, then the head is probably the pointer of the last one, I think. Yeah, the next becomes the head. So head is always none, I assume. That's why they are using option there. Because obviously you want to know when is the end of the linked list. And increases the length. Okay, so here it changes to the new node. So that's the head is gonna be the last element of the linked list always. They assume that it's gonna read the memory, which makes Rust drop the memory. No, so it looks like it uses the replace instead. But they don't drop the memory, they just replace with a none value. Oh, they are reading here. It's probably so they read first and then they move. The source read to drop the destination. So they drop the previous value and then adds writes the none there. Makes sense. Again, there is these annoying things here, but I don't think there's anything I can do about this now. Probably when I go over, spend some time to go over the Rust C compiler, I'm gonna hopefully be able to figure out like how to translate this stuff here to actual logic that makes sense. I don't understand this very much actually, and what is happening here. So from what I remember on Rust, the map, that's the thing, I'm not really sure if it's valid for everything, but I do remember that the map, when you map over a vector, is lazy. It means it's not gonna iterate through the elements right away, like it does on JavaScript and I think Python as well. It's gonna just create the expression, and then once you iterate over the result that you get from the map, then you do the actual computation, as far as I remember. There's a lazy thing, but here I'm not really sure if it's the same thing or not. Or probably something that I should ask. This here is just returning an option of type D. And there is now, I assume that's gonna be the same type of the thing here, obviously. Then how do you know if you can map on the option or not? How does that work? And here is kind of confusing as well, because what does it mean for the node.next here? So obviously, on a concept level, it's very easy to understand, just reading, replacing with none, the last value, and actually is the first value. No. Now I don't know. I think it should be the last because the head is always the last according to this. Because reading is replacing the last value with none, and is mapping over that and decreasing the length. Assume it's just putting the pointer on the previous one from the head, but not really sure. Yeah, so basically, this pattern here I was talking about before. This is the first time that I see this here, but I think it's very obvious and easy to understand what's going on. Then in Rust, you're gonna have the built-in types, built-in iterator types, which are the things that actually do the for loop when you're looping over something. Because internally you need to know the memory layout in order to loop correctly from one element to the next. And I think here what's doing is basically overloading the built-in types. So when you implement your iterator yourself, it allows you to change the behavior of what actually happens when you loop over. It's basically the same thing that you have on C++, but I think C++ is slightly different from what I remember, but I don't remember exactly how. But I know that there are differences, I think. And obviously, when you're implementing on C++, you would implement inside of the class, I think, or you would create another class. Hmm. I don't remember really well. I think we need to create a specific class inside of another class that has the correct name, and then just change the type on the template. I don't remember it all. The rest seems pretty easy to understand. I have to ask about this. So I'm just gonna read the response and then I'm gonna ask about these two things about the map here and the drop here. Then I think I'll do some quizzes. Oh, this one I remember that is a little bit tricky. And it's again about the parsing of the macro. How does the macro parse whatever expression you put here? I think the first one, it is 1. But then the second one, I don't remember. I think it's probably 2 still. I remember there's something. Yeah, I think it's because. Hmm, I think it checks first the first elements and then it matches whatever comes first. So there's one of these here that is not gonna give the expected thing here, but I don't remember how it works. I think it's this one that is 1. Yeah, I think it's like this because this one is gonna match these tokens here first, and then it's gonna output 1. I'm not really sure though. Oh. I don't remember the reason why though. Yeah, this explanation is not very good, but it's basically saying that the based on the way that the Rust parses the tokens. On the other ones is just gonna match because each one is a specific token, but then this one is unreachable because it matches this one. But I don't understand why though. It doesn't do a very good job, I think, to explain. But I guess it's just like yeah, it's like it's saying here, it decomposes to this. So the point is instead of looking at the pattern in a linear way, you have to look from the compiler's point of view. It's more like a tree structure because it's gonna be tokens and not the actual text. I don't know. I think it's because I'm changing the changing the page. Right answers. Yeah, so it's basically already addressing the clear and the drop, and saying this can cause stack overflow. Not really sure why it's bad though. The recursive drop chain allowing blocks to drop blocks to drop blocks. Now it's saying that a recursive drop chain causes stack overflow, so they wrote the massive blocks because of that. Not that this is gonna cause a stack overflow. Is that whenever you have a recursive drop chain of boxes, it does cause a stack overflow. Not saying necessarily that is wrong. It's saying that is bad. It's over engineered. It's basically saying that it was dropping the reference, not the element. So it didn't do anything to the actual element. I think it should. work here, maybe? Actually, I'm not really sure. Maybe it's an error here because you're getting a I think it's an error because you have a reference first and then you have a mutable reference, so it could cause a dangling pointer on the first one. Or unexpected behavior, because if you change A through R2, then you'll fuck up the R1 reference. Not really sure though. Oh. So can only have one reference or mutable reference at a time. Most one mutable reference or any number of normal references. Yeah. You can't have both at the same time. This is one I also kind of remember. There's something to do with this one being a new S. It gets created there. I think it's 1, 2 there. Then it gets dropped immediately here, I think. Then it prints true here. Yeah, I think it's just 1, 2, 3, 4. So first D1 gets dropped here because it has these 2 dots. So I'm not gonna use it, so it drops. Then it prints X, which is true. And here, same thing, it drops D. But there was something about the S there. Don't remember. Yeah, I don't remember really well. Hmm. It was 1, 2, 4, 3. And it's basically because the lat, I forgot about this. I think that's when you have this pattern here, the underscore, and you do you assign it, it gets immediately dropped. But then if you use the lat, it's gonna wait until the end of the scope to drop the value. So if you don't put anything, it drops immediately. If you put the lat, it drops at the end of the scope. That's why this one drops the D after. This 1, 2, 4, 3. Makes sense. Hmm. No, I'm not really sure. I'm just gonna guess. I have no idea, but I think it's probably an error for some reason, but I have no idea. I don't understand why. There's an error because you need to implement the size. Yeah, I'm gonna stop here. So next time I'm probably gonna continue to do this. Or I'm gonna convert micrograds to Rust. So see you then.